So part C, going on to the hypothesis test. And the hypothesis test, so H0 would be lambda is 0.4, because we said it was 0.4 per day. But for H1, they say it's going to be less, so less than 0.4. And we're testing this in 42 days. So in 42 days, then X is a Poisson. 42 times 0.4 is 16.8. And of course, you could set the hypothesis up with 16.8 here and less than 16.8 there if you wanted to. The probability that X is less than or equal to 8 in that situation there, then, so let's grab the calculator and just go with it. Less than or equal to 8 with 16.8 is 0.0141. That's quite small, isn't it? 0.0141. So 0.0141 is less than 5%, therefore reject H0. The evidence suggests it is less. Evidence suggests, what are they saying? Evidence suggests lower in winter. Yeah, the number of calls lower in winter. Now I'm summarizing for the video, but you copy exactly what it says. The number of calls, it has to say the number of calls, and it has to say per day. The number of calls lower per day. Both of things need to say there. Just copy exactly what it says there. Don't take any shortcuts as you do that. Now, lots of reading going through to the last bit. This is quite nice though, isn't it? So B is a Poisson with a mean of 0.2. So the total is a Poisson with a mean of 0.6, isn't it? But how many days are we going to go? So for n days, then we're a Poisson with a mean of 0.6 times n. Now we want the probability, this is C, the probability that C is equal to 0. So this is nice because you've got the formula to remember. So it's e to the minus lambda to the x, which is 0, over x factorial. And we want that to be less than 0.001. Well, of course, 0 factorial we can just ignore. Anything to the power of 0 we can just ignore there. And so we've now just got that e to the minus 0.6n is less than 0.001. So if we learn it and divide by minus 0.6, that should just about do it. Yeah, so we've got that n will be greater than, and it's a greater than because I've divided by a negative there, 11.5. So if it's going to be greater than 11.5, it's going to have to be 12, because we can't have 11.5 there for n days. Write down an assumption that needs to be made for the model to be appropriate. So it is the rate is constant, the rate of calls are constant, and calls are independent. That sort of thing there. Number of calls are independent from the two different things.